Geez, I had to turn off and on this thing like 3 times before it actually worked. Probably don't need it up that loud, but we are back to learn Unity. Down in that little tiny box over there. I forget, they have a pathway after Junior Programmer. Wasn't it just some, like, other dumb thing? I guess that's what I can do next. Because we had the Essentials, and then Junior Programmer, and then they have something else after that. Right? I'm just gonna look really quick. Yeah, Creative Code was the next one. Ready to create immersive worlds. Its pathway covers core skills in 9 expressive domains, including lighting, animation, and effects. Foundation, beginner. Foundational, beginner. I don't know if I need to learn this one. I would just make what looks cool to me, right? Well, that doesn't matter right now. I'll probably still do it anyway. Maybe, I don't know. This Junior Programmer thing was my main concern. But let's get into it then. We already did all that stuff. Okay. Now we have the apply object-oriented principles. Wait, was this the right one? Yeah, I did this one. Yeah, I mean, I guess this is the right one. Just making sure I'm actually doing the right thing. Okay. I guess we'll start. So this will take approximately 5 hours, but this whole course section for the first mission says it'll take an hour and like 30 minutes. So, let's see. This one is Abstraction and Object-Oriented Programming. So let's see how this will go. Oh. Do they have us open anything right away? I'm not sure if it will, but for right now, I'll increase this size. Just to show what I'm looking at. I guess they're always in these little boxes, so I'll just cut it off the screen. Okay, so we're ready to work through our existing code and improve it without changing its external functionality, a process called refactoring. Refactoring is an important step in the development process, in which you can clean up any messy code you wrote earlier. You also re-examine the ways your code will be used in future iterations of the project. In other words, in the development phase, you wrote code that works well for now. In the refactoring phase, you will revise the code to work well later. In the last mission, we introduced the concept of object-oriented programming, and throughout the junior programming pathway, you've been implementing some of its best practices. Now you'll examine each of the principal pillars: abstraction, inheritance, polymorphism, and encapsulation in depth, and use the paradigm as guidance to effectively refactor your code, beginning with abstraction. As you work through this final mission, you'll continue refining the inventory project that you built in the previous mission. What inventory project? They had us do a breakout game, and they had us do an RTS thing. Do they mean the RTS thing? I feel like we didn't really do anything but change the color. The first pillar of OOP is all about keeping your code clean and simple for the programmer using it. Whether that is you or someone else, abstraction is the process of removing complex code from the scripts where the other programmers will see it, and only exposing the functionality other programmers really need. When you abstract out the details, you reduce duplicate code and provide easy access to the most useful functions. You're actually already quite familiar with this pillar, because you've benefited from it frequently throughout this pathway. Whenever you call on a method to perform a task, rather than writing out all the code out by hand, you're benefiting from abstraction. Let's take a look at the situation where you used abstraction during Create with Code in Unit 4 gameplay mechanics. You created some functionality to spawn an enemy wave. When you initially wrote the code, you put it in start method. Since start only runs once when the game loads, if you wanted to spawn another enemy wave, you would have to paste that line of code elsewhere in your script where you wanted it to occur. Having to constantly rewrite or copy and paste the same lines of code over and over is inefficient, prone to error. It also means that later refactoring becomes difficult, as you have to search throughout all of your scripts and rewrite all the references over again. Instead, you separated out spawning functionality into its own method and called that onStart. You created a higher level, more abstract function called spawnEnemyWave. You are then able to spawn enemies anywhere in your script from a single line of code, and if you needed to refactor it later, you could do it in a single location. Additionally, you and your fellow programmers no longer need to worry about the specifics about how the enemies are being spawned. All that matters is the more abstract concept. If you call spawnEnemyWave, it will be spawned. Your experience with abstraction isn't limited to methods of your own creation. In fact, you've been benefiting from abstraction every time you call on a method built in Unity. Adding force to a rigid body involves a great deal of mathematics interacting with physics system. However, since Unity has provided you with this simple abstraction high-level function, add force, you need only call on the add force method and give it parameters that are relevant to your needs. You don't even need to understand Unity physics to successfully add force to your subject. Okay. I mean, yeah, that's nice. We don't have to do all the mathematics. It's just saying that we can make it dumb baby numbers so we can understand it. Remember that an important part of refactoring code is to improve its functionality without changing the way that other programmers interact with it. Abstraction plays a key role in this. As long as the method call and output doesn't change, you can adjust the contents of the method without the other programmer ever knowing. This means that you can safely refactor your code without risk of breaking anything elsewhere in your project. Let's look at an example. Integer triple results, okay? And the above method, calling the script, passes it in an integer and gets an output that's been tripled. The approach to get the output number is a little ineffective, so you could refactor the code to look like the following. Okay, I mean, that makes sense. I feel like calling it refactoring is a bit simple. Where you're just making it not as dumb. Even though the content of the method has been rewritten, the way the method is called remains exactly the same, as does what gets returned. Therefore, any call to the method throughout the project will continue to work. You rewrote it to be smaller, but it does the same exact thing. Though to me, as long as it does the same thing, I don't care. It makes me wonder what a lot of solo projects coding looks like. Like, how many weird things would they have that another programmer wouldn't be able to understand at all? Implementing abstraction in the project. Let's implement abstraction principles we just learned about refactoring user control and the inventory project, all of the functionality involved with selecting forklift and moving it to the desired resource in the update method. But what if later on we want other factors to be able to control these sections and actions? Let's abstract the functionality out into two new methods. To make that possible, we need to open the inventory project from the previous mission. I'm guessing that means the junior programmer project, so I'll just start opening that now and keep reading. Locate the user control script in the scripts folder and open the Visual Studio. Above, update define two public methods with no returns and name them handle selection and handle action. Handle selection will manage everything that occurs when the user left-clicks one of the forklifts in the application. We'll still need to check for the left mouse button in update, but everything else will be moved to our new method. In the update method, select the contents of if input get down statement and move it to the handle section. Okay. I'll just wait for the rest of this to load. I feel like this is probably going to be one of those things where they're just like, now, give us everything that you did for this new project. Just waiting for it to load. I guess I can shrink this really quick. Make it in our baby corner. Give a good old yawn. That's a user control, right? Yeah. User control script. Down, 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 down. Just loading up Visual Script now. This is my game devlog stuff, but Visual Script will be loading soon. Yeah, that's a yawn. Always so strange to me when I get some people message me and then they just do one-word messages only. Like, what are you like trying to do? Supposedly want to talk, and you're gonna give me one-word messages? If you got something going on, fine. But if we're like actually talking, let's actually talk. Anyway. Yawn. Wait, it didn't even load the script I was trying to load. Okay. They want above updates. Handle selection, handle action. Okay. Select the contents of if get not down. In the update method, select the contents of if input get button down statement and move to handle selection. Oh. Apparently they want me to do this. Oh yeah, because then I can just put handle selection there. I understand now. My nose is leaking. Geez, I just move over slightly and then nose starts pouring. In the if button down statement, all hand selection. Yeah. Wait, what? The application, locate the else if, move its contents to handle action. What's the problem here? Eh. What is she? What problems? Oh, I just need to know that. Okay, that's why. Makes more sense. And it's a list to test it. Like it is working normally. Functioning properly. Okay. I guess that one is done. I wonder why these later tutorials don't have any, you know, like speaking videos or anything. This is so far all text, which is interesting. The next two pillars of object-oriented programming, inheritance and polymorphism, are deeply intertwined. Inheritance, much like the name implies, focuses on parent-child relationships between different objects. Polymorphism is a result of inheritance and refers to the process of the child class modifying what inherits from its parent's class. Used together, inheritance and polymorphism can reduce the amount of code you have to write in an application. Okay. Inheritance is the process of creating a primary class, also known as a parent class, from which other classes called child classes can be created. A child class takes on or inherits all the features of the parent class automatically. It's common to have different classes share similar features in an application. For example, a video game may feature many different types of enemy classes, but they are likely to share the same core features, such as managing their health and the ability to deal damage to the player. With inheritance, the need to write that health and damage functionality for each individual enemy class is eliminated, so that you can focus on writing functionality that's unique to each class. You've already been making use of inheritance with every script you've written in Unity so far. By default, whenever you create a new class, it inherits from MonoBehavior. MonoBehavior is the basic class from which all core Unity scripting functionality inherits. Without MonoBehavior, you wouldn't be able to call onTrigger getComponent or even start an update. In the diagram above, it might appear that all of the child enemy classes will lose their ability to access Unity functionality because they exchange their inheriting class from MonoBehavior to enemy. Fortunately, since the enemy class inherits from MonoBehavior, the children of the enemy class are also considered children of MonoBehavior. It doesn't say that in the diagram at all. You're a liar. With polymorphism, although inheriting core functionality from a parent class can be helpful, there are many situations where you don't want the child class to perform exactly the same action as the parent class. Polymorphism allows you to change the functionality of what an object inherits from its parent class. Deal damage. Enemy. Player health minus equal 10. In the above example, the enemy class has a deal damage method that removes 10 points from a player's health whenever it's called. The thief class, a child of the enemy, can call this method without declaring it in the class. Okay. This is fine if you want the thief to deal exactly the same amount of damage, the enemy class. Ugh. These changes are accompanied through the process known as method overriding. Method that you want to override in the parent class must first be marked for overriding. This is done by making a virtual method. Identifying a method as virtual indicates that it can, but doesn't have to be, overridden. That is ideal for the current example, because while the thief child class may need to modify the deal damage method, another child class, such as the scoundrel class, may not. Once deal damage is set to virtual, the thief class can override it by creating its own method for deal damage. Here, instead of virtual, we'll use the override notion. You can now add new functionality into the method, specifically for the thief class. Okay, so they're all inheriting from the enemy class. So you're just taking you're using override on deal damage script in the enemy class, and you're overriding the stuff called player health, and you're making it 2 instead. So I wonder if I would be able to use things like that in an actual RPG. The thief class now deals a smaller amount of damage than the parent class. It also calls one of the thief-specific methods. Now when deal damage is called an update by a thief object, the customized deal damage method will be called instead of a parent method. Create a new unit type. In the project brief, you'll see that one of the items to be built is productivity unit. This unit should increase the productivity of any resource type that the user has selected in the scene. The user will select the resource the same way as the forklift. Left click, select the unit, right click to select the resource to move. Productivity of a resource should only be increased while the productivity unit is actively working on it, and if the unit leaves the resource, it should return to a normal production rate. Here's what that might look like in your project. Okay. The forklift is managed by the transporter unit script, which itself is a child of the unit class. If you look at the unit class, you'll see that all of the functionality we need for movement is there, so it makes sense that our productivity unit should become another child class of unit. In the prefabs folder, locate the productivity unit prefab and add it to the scene, this worker, that will improve the quality of your resource files. Okay, so let's go to prefabs. Actually, it looks like I should change my scene first. But it's fun to see how teeny things are. Okay, so now we go to prefabs. It more or less looks good to me. Okay, so that's in the scene. Create a new C# script and name it productivity unit. Okay. Script. Great. Productivity units. Did I spell that right? I think so. To make the productivity unit class inherit from... Double click it. Oh yeah. Let me bring it to Visual Studio first. Okay. Remove mono behavior from the class. Declaration and replace it with units. Okay, so we're gonna go in here. I'm gonna remove mono behavior. Replace it with the units. Doesn't make sense. Why does it not do it? Okay, an error will appear in your script that says does not... Oh, okay. If you look at... You'll see the following code. Abstract... Protected abstract building. All you need to do is override that method. Okay. Did it for me? Building in range. With that error is all I need to do is override that method. That error, well, let's explore the functionality we automatically gain by simply extending the unit class, save the productivity unit script, and return to Unity. Didn't say to put anything in there, so I'm just gonna get rid of that. Okay, so and they want us to go over here. Notice that the class child is automatically given a float and speed. Okay, let's see. Okay, yeah, it has float and speed. We hit the play button. We can move them. They already have an animation set on the prefab, so they move around. The work will navigate 30 source panel automatically. If you right click elsewhere, then it will move. Okay. I guess I didn't check if it uses the resource file. Okay. Now override the building range method. Okay. So to complete the building in range method, you'll need a variable that will keep track of any resource pile that the user has selected. At the top of the class, create a resource pile variable named mCurrentPile. Okay. So make some variables. Resource pile. Current pile. Equal null. Then we want a public float productivity multiplier. Did they capitalize this? Yeah. How do you spell multiplier? Multiplier. Better safe than sorry. Make a public float of 2. Return to the building range method. Decode what happens when productivity unit is in range of a resource file. This code will run every frame. We want the production speed to increase during the frame when the productivity unit comes within range of a building that is resource file. Then we want to prevent this code from running in the next frames, or else production speed will keep increasing. Okay. Let's see. So we want to go to building in range. I'm going to override it. If mCurrentPile. Null. Then we want resource pile. Wait. Resource pile. Pile. Target. As. I haven't used as. That's a scary new lingo. If file is not equal to null, and current pile equal pile, then current pile production speed. One of these. There it is. Multiply equal to productivity multiplier. Okay. The notion as resource pile sets the pile variable to mTarget only if the mTarget is resource pile type. If mTarget is base, these types won't match and pile will be set to null. This is an effective way of checking whether mTarget is a resource pile. If it is a pile, exclamation part equal null, then mCurrentPile is set to that resource pile and its production speed is doubled. On the next frame, the if statement at the top of the method will prevent this code from running again because mCurrentPile will be set to a value, the resource pile. One other interesting thing to note in this code is that you are able to access the mTarget variable which is a protected variable in the parent unit class. Protected variables are like private variables, but they can also be accessed by any child classes. You were only able to access it because protected unit CS derives from unit. Save the script and return to Unity. The public is for everything to inherit, pretty much. And protected would just be the parent only. Okay. Note the production rates doubles once it does. Okay. So now that we did all of that, it should just make this go faster when we have it hitting play. So I'll just throw this thing over here. We see how fast it's going. And then we'll move this guy over here. I don't know if I can tell if it's going faster or not. I'll believe it. To finalize the productivity unit, you need to make the resource pile's production rate return to its previous value as soon as the unit leaves, as it described in your unit class. This is managed by goto method. But if you look at the class, you'll notice there are not one, but two methods that have this name. Methods can't share names, right? In most cases, this is true, except for the special circumstance referred to as method overloading. Notice that both goto methods have different parameters types and have different functionality. Method overloading effectively makes a single method multi-purpose. When the user selects a target, this pair of overloads will handle the navigation depending on the type of object they selected. The first goto method takes a building class as a parameter, which is collected when the user right-clicks a resource. Okay, second goto situations randomly point in the warehouse and the resource file. You could write this as separate methods, but then you'd have to remember multiple calls. With method overloading, you only have to remember one call, and the data types being passed will determine which code to run. This is yet another feature you have seen in Unity, and whenever you call a method from Unity API, and have options for parameters to use. You're taking advantage of method overloading. For example, transform translate has 4 separate overloads in which you use during the first unit to create with code to get a car moving on the road. Okay. I was gonna say, it didn't tell us to do anything, so the productivity unit needs to check to see if it's currently working on a resource file, and then if it is, perform what occurs in the base goto method and return that resource file's production output back to its original value before moving away. Let's override the goto methods to do just that. In the productivity unit script, create a new method called the reset productivity. Both of the goto methods require the same functionality, so we'll build one method to call from both. Next, check to see if the mCurrent pile variable is null. If it isn't, then divide the speed to return it to the original value and set it to null. Okay. Reset productivity. Production speed. Productivity multiplier. Equal null. Okay. Create a new public override go-to method with a building as the target parameter. Go to building target. Reset productivity. Oh, the base go to target. Okay. The base label tells the script to run the original method in addition to the new code in this override method, or repeat the same exact process for the other go-to. Okay. Just the same reset thing. Oh. I meant save, not that. Not that one. I also wasn't showing this. These methods will run as soon as the user selects a new location for the productivity unit. Before moving it or return the production speed of the current pile back to its original state if productivity pile was currently selected. Save the script and return to Unity. Playtest again, send your worker to a resource pile and select the pile where the worker reaches it. Observe the increased production rate, the resource pile, and send your worker. Okay. So ironically, now I can take it down. Oh yeah, it's definitely faster when they get over there. At least it looks faster when they get over there. I don't know if it actually is faster or not. It's kind of hard to tell. It looks faster. In theory. Okay, encapsulation in object-oriented programming. Let's get to it. Much like abstraction, encapsulation focuses heavily on maintaining a level of separation between the underlying complexity of your code and other code that uses it. Due to their similarity, you'll sometimes see some followers of OOP practices group abstraction and encapsulation into a single pillar, typically under the header of encapsulation. However, we're making a distinction that we think is important. While abstraction is all about summarizing code to make it simpler for other programmers, encapsulation is all about protecting values in data as if they are enclosed in a capsule so that you can control what others do and do not have access to. Give them access to everything. Who cares? Who cares? Okay. Yeah, I don't see any reason to do that. Making a variable public exposes it to the inspector, but it also makes it available to be changed in other methods in your application. Good news. There's a way to make some values in the inspector, otherwise known as serialized, without exposing them to other code. This gives them the freedom of modifying variables in the inspector while still keeping them safe. In fact, the access modifier of a variable, public-private, actually doesn't control serialization, but public variables and are serialized by default. You can easily expose your private variables in the inspector by adding serialized tag. Oh, wait. So you can just do that at the top and you don't have to do it to everything else? I didn't know that. I thought you had to do it to each one. Well, that's good to know. Find a vulnerable public variable in your project. What about variables that you really need to be public? How do you protect them? You can't make this variable private because it would cause errors in the other scripts that you need to access, but leaving it public means potential, means it's vulnerable to potential misuse. Let's cause some mischief to demonstrate the problem. For experimental purposes, add a line of code at the end of start method that sets the manager instance to null. Test your application. By selecting color, you will now get a null reference expression. We need some way of preventing this kind of misuse while granting public access to the variable. Who would do that? Who would actually care? Someone wants to data mine my game, I'll just give them the code. Like, who cares? Come on. Essentially, what we want to do is make the variable read-only, allowing other classes to get the value but not see the value. In order to do this, we can use the C# get and set methods, which will control how and when our variable can be used in main manager. Add an accessor to the end of your main manager instance variable. Without the successor problem to fix this private setter, we should resolve the error. With this code, you can now set the property's value within the class, but only get it from outside the class. It's encapsulated. It's only a modification from its own class, safe and misuse and corruption outside world. Okay. I mean, I guess I'll just do that. Okay. Locate the need for setter validation. The getter and setter you added above represent the most basic form of encapsulation, where you're simply getting and setting the value. Nothing fancy. The simple implementation is called auto-implemented property. Okay. But in addition to restricting if or where a value can be set, you might also want to restrict how a value can be set in a more customized way. in a more customized manual way. For example, an application that allows another class to set the date, you might restrict the month to a number between 1 and 12. Or you might want to prevent the use of negative numbers. In our warehouse project, there's a place where we can do precisely that. We have a production speed variable that should never be set to a negative number in the resource pile. So yes, locate the exposed public production speed. Okay. Resource pile. Oh. Also locate the line productivity units where the public variable is multiplied by a constant. Okay. There's nothing stopping us, a future version of ourselves, or some other carefree developer from setting this to a negative number, which would cause problems for this project. But why would they do that? If they knew it wasn't supposed to do that. I don't know. For experimental purposes, mischievously modify this line of code to subtract... Okay, yeah. I don't think we need to do that. Make a property with a backing field. Perform validations or calculations within a greater or within a getter or setter, you need a backing field for your property, a private field variable that stores the data exposed by public property. Let's see this in resource pile. Add a private member variable backing field using the same name as production speed, but store the value in this new private field instead. Okay. With the backing field declared, you can now manually add the get and set functions, which receive or assign the backing field when someone accesses the public property. Get. Oh, it has to be outside of it. I don't know. It's not doing it. No, it's still doing it. Get space. There we go. Set. No. Oh, God. Why does it do this? Set. Still doing it. Whatever. That's why. Or not? Delete semicolon. No, it's return. It's not period. Okay, well, everything else should be right. Why isn't it working? Where the heck did I choose to get that thing? I think that's what the problem is here. Oh, wait. Okay, I figured it out. It took me a lot longer than it should, but I did it. Okay. Ah, that was silly. I've been looking at the same thing. I'm just like, oh yeah, it doesn't have the float there. It doesn't have the float there. And for some reason I wasn't connecting that in my head. Then, since the data is now stored in the backing field rather than the public property or references to the property, should be swapped with the private field in resource CS. Replace the two references to production speed with M production speed. Yeah, they're incorrect. Oh wait, this is for resource pile. Oops. We want M production speed there. If my M key works. Wow, there. Okay. Really gotta actually read. You have to read. Implement center validation to prevent negative numbers. Okay, finally with everything configured, we can now implement a validation check within the set method, ensuring the production speed is always a positive number. In fact, we can even display a warning message in the console if negative number is attempted. Within the set method, add an if-else statement that displays a warning message if the value is negative, but successfully sets the value if it's positive. Wait, where are we setting this? Everything, we can now implement a validation check. Like the set method up there? Is that where we want to do that? Or do I just like want to go over here and go? No, I think they want me to do it here. Wait, what is this? What is this doing? I'm not sure what it is doing, but okay. I feel like this isn't the place they want me to type this. But now I don't understand. Now I don't understand. I don't have a set method besides this stuff. It looks like they want me to put it here. I get it. They wanted me to make it here in general. Okay. Now it's correct. Okay, so test your application, see what happens when the production speed is set to a negative number. It should display the error message. With the setter validation fully implemented and tested, you can now return to the productivity unit to function as normal with a multiplication rather than subtraction operator. It already had a multiplication operator though. That's what you had us do before. Well, okay then. That was a strange one, but I guess I got through it. We're almost done with this mission, which is nice. Just a little more, and it has been going pretty quickly. It hasn't even been 2 hours. Hasn't even been 2 hours. I guess this one takes longer because there's a bunch of reading. As you work toward finalizing your project and preparing for publishing, it's important to identify and resolve, either during or after refactoring, any bottlenecks that remain in your code. Unity's profiling tool is ideal for locating hard-to-find issues that may be driving down your frame rate. The profile produces a detailed report of precisely what is occurring in an application frame by frame, including what scripts are called, how many memory is being allocated, and visuals are rendered on the screen, and more. You can see anything that affects your project performance in the profiler. Your project's performance depends largely on the computer it runs on, which is why it's important to profile your project on your specific target device, or if your target has a range of supported hardware, such as a desktop, to profile on multiple devices with different specifications. If you run this project on a new high-end gaming PC, you're likely to get very high frame rates, while the experience might be completely different on a 5-year-old laptop with onboard graphics. To make it easier to identify common optimization issues, we created a highly unoptimized scene for you to review as you explore the profiler for the first time. With this in mind, be aware that the numbers you see in this tutorial will likely not be exactly the same as those on your own computer. However, regardless of your frame rate, you'll be able to see measurable results when you optimize the scripts. Okay. Yeah, I guess throwing everything in the same place is good. Optimize folder in the project and open it. Okay. Optimization folder. Save. Open it up. Got a floor. When you first open the scene, you only see a gray a gray plane in the hierarchy. You'll also see a manager game object with the Optum manager script attached. Press play and observe the scene. That is definitely a bit chunky. Oh yeah, that is a bit chunky. In play mode, thousands of forklifts appear on the plane, all rotating and moving around within a set boundary. Open the Stats tab to make a good note of the current frames of your computer. Yeah, I did not have the Stats tab up. Our FPS is 9. Shadowcaster's level isn't even having all of them in frame. And we're just getting 9 frames on my computer. That's pretty good. They have about 9 also. Exit play mode and look for the optimum script. And the inspector... Manager script, okay. We'll open that up. This script is responsible for the generation of the field of forklifts. Note the variable for the forklift prefab, an instance counts and the size of the boundaries. Select the manager object in the hierarchy, then the Optum manager. Components change the instance count to 200. Recenter play mode and observe the change in FPS. Yeah, now I have more FPS than they did. Those are all moving fine. Okay. The reduction in the number of forklifts in the scene increased the overall FPS in a situation where frame rate matters over anything else in the application. This might be a valuable optimization solution. However, what if the application required both 2,000 forklifts and a frame rate of 60 FPS? With your requirements in mind, it's important to figure out precisely where the bottleneck is occurring. Was the frame rate lower in the first example simply because there were 10 times as many meshes on the screen? Is it because they're all moving? Is it something else? Finding the answer will tell you exactly what to address. Profiling will give you a snapshot. Okay, I get that. That's understandable. Let's look under the hood. You use processing in the scene. Set the instance count back to 2,000, if you insist. It has been set back to 2,000. Open the profiler by selecting Window Analysis Profiler. Window. Oh wait, I'm looking at my scripting stuff. I mean in Unity. Window Analysis Profiler. Oh good, this is another window that can't be shown. Can I even grab this on here? Oh, it doesn't even look like I can actually grab this with something else either. That's kind of dumb. Dock the profile window to the project window. Well, I guess I can do that to show it. That's true. That is true. Open it over there for now. Okay. Currently, the profiler is completely blank because no data about the scene has been gathered. The profiler begins working when you start the play mode, ensure that the profile's record button red dot is active, and then press play. Okay, profiler, red dot active, press play. This is with 2,000 again. Currently the profiler is complete. Okay, the profiler will begin to log a color-coded chart of performance data after a second or two. Exit play mode. Okay. We exited. Got a giant drop-off somewhere there. Player loop. Behavior. A lot of juicy info. Detailed outline and everything. The top half of the profiler is divided into modules. Starting with CPU usage, this will be the only module we'll use in this tutorial. Okay. The module contains a chart of various categories and operations that making use of the CPU. On the left side of the module, there's a color key for these categories, spikes that showed. Notice the blue background isn't a background at all, but a representation of scripts running. Even from this very high level, we can tell that something is likely going wrong with our scripts, since they're taking up orders of a magnitude more processing power than even rendering the scene itself. We'll inspect the script shortly. Okay. Yeah, that's a lot bigger than anything else. Establish a millisecond budget. The bottom half of the profiler shows a visual breakdown of exactly what's occurring in each frame. If you don't see the bar graph visualization, on the bottom half of the profiler, select Timeline in the drop-down directly below the Profile Modular selection. Okay, well, we got this. We got this, we can see it. Okay. The white vertical line on the CPU graph represents one frame. That was played in the application. Left click and drag along CPU. Select the frame where the CPU spike. Okay. Total number of time, milliseconds when profiling. Okay. Explore the profiler timeline. Just the update method. It takes 98 milliseconds to complete, which by itself goes over our milliseconds budget many times over. Also note that there are 2,000 instances of the script running in this frame, which is significant because we know that we're generating 2,000 forklifts in Optimum Manager script. Somehow these two factors must be related. Why would the script run 2,000 times? There must be one instance for each forklift. We select the Optimum prefab on the Optimum Manager. We discover the Optimum is attached to the prefab itself, which means that there are indeed 2,000 copies of the script running. Okay. There's a lot going on in the Optimum script update method, so let's get a little bit more help from the profiler. We can profile specific sections of code by adding profiler begin sample, profiler end sample methods. I don't know if this one matters too much to me. Profiler end sample, okay. Finally add one more. I don't really need the sample thing, so. Capture the new data, CPU, create timeline. I mean, it's good to know, but I don't need it right now. I don't need it. Optimize the code. Return the Optimum script and scroll down until you find the move method. In move method, call an update. Hold the control windows. CMD Mac key and left click to move jump down to the method. Or I could just go to it. I now see move. Okay. The moon method calculates several variables and iterates a for loop between 1,000 and 2,000 times to calculate the new position of the forklift. Multiply that by 2,000 forklifts to 4 million loops, and consider that this method runs once per frame. It's easy to see why this method is so slow. These calculations are redundant to current velocity, which is calculated in the boundary track code. It is easy to simplify this method, so it only takes care of moving the forklift. Replace the body of move with the following line. So just to show this whole line of code. Bam. Don't want it. Man, they don't like me hitting delete. Instead, we want transform position equals transform position plus current velocity times delta. Wait, it's time delta time. I don't know why I said delta. That just regulates the frames also. Save the script and return to the editor. Clear the profile data and capture data once again. Okay, clear it. And now it's running at almost 100 frames per second. And we can see that our scripts are now not covering the whole entire screen. They're still pretty big. And they still spike now and again. But they're a lot more manageable. And we can actually see what's going on. Also, I had this up again. Let me just show that again. Just show it again. That is now running as it should be, at a proper frame rate. And we can see here, again, just to show. Scripts do go up a little bit, but it's not the whole entire screen. Okay. Oh. Yeah, theirs jumped to 67 for their frame rate. I guess my computer is better than the one they were using for this example. And now, job preparation. I don't want to do job preparation. I want to not do that. In this tutorial, you'll review guidance on evidencing your progress, updating your portfolio and resume, preparing for interviews. No. Wait, is this actually the end of the pathway? I thought this had 2 missions in it. This is the last mission? What? Or are they not counting the quiz or something after this? Is that its own separate thing, maybe? I don't know if this will have a quiz. This is their certification exams. I was kind of considering a certificate. I can say it. Don't worry. I was kind of considering it. But I don't even know where you buy it. Like, I clicked on this stuff before and tried to read through it, and I don't know. Anyway, review your resume and portfolio. Even if you don't plan to apply for new jobs now, this is an excellent opportunity to assess the progress you've made and update these documents. Identify appropriate job roles. First, return to your career research document you started in career research preparation. Review your research and use it for the role that best fit for you right now. Common job titles that align to this pathway include Junior Programmer, Junior Unity Developer, Junior Unity Software Engineer, Junior Gameplay Programmer, Junior 3D Programmer. When searching for job listings, try using keywords like Unity and C# to help find appropriate roles. As you explore different job listings, update your career research document with the following information for each job role that you are interested in. Update your portfolio and resume. Prepare for job. Okay, so that's just actually like tips for help on what you can do. Establish career perspective. Must love playing video games. Must have attention to detail. No. Summary and next steps. Learning journey is using what you learned in Introduction to Real-Time Experience Design tutorial and take design and publish your original game Unity USC Games Unlocked course to create your next real-time creation. This course introduces the agile design process and guides you through creating a game. While this course is game-centric, you can still use the design process to produce any real-time project. We recommend taking this course to build an additional project to showcase in your portfolio. Okay. Understandable. Okay, so they did still have an exercise and a quiz. The quiz probably is fine. And then we'll get a downtown park. Okay. And then when we do this, we'll be done with this whole entire unit in theory. Programming theory in action. I wonder what that's going to be. It says that it's a 30-minute thing, but will it be 30 minutes? 9 questions out of 12. Okay, well, before we start that quiz, I'm gonna go to the bathroom really quick, refill my water, all that junk. I got some crackers. Maybe I'll have a little snack. Either way, I'll be right back. Alright. So. Let's just close that for now. Be doing this quiz for a little bit, at least. Now, I already, just to say again, I have dyslexia, and it's not like I'm sitting here studying from a book. I'm literally doing these courses one after the other in like 5-hour sessions, and not actually like studying how a normal person would. So I don't claim to know all the vocabulary and junk. I do understand a lot of this stuff now as I've been doing it. And I've shown that because I've been able to actually make projects, but all their precise words and junk, I don't know. Some of them I get after I've seen them several times, and reading stuff aloud can help me learn it, but I'm not always that great at this stuff. So I'll read through this junk, try and figure out what it is on my own. Then if I get all this junk wrong, we'll just go through it again. Keep going through it until we get it right. Now see, this isn't right already, right? Classes should be organized and written such that each class has a singular purpose. A class doesn't have a singular purpose. Like mono behavior is the class, right? And that already automatically has several purposes, doesn't it? Extension method is like the go-to thing we're looking at. This is asking when you want to use an extension method, and I'm saying what it said in the stuff that I was just reading. In order to extend the functionality of an existing method using the same method name, which makes sense to me. Which of the following statements are true about parent, base, and child-derived classes? A class can only inherit from a single class, bracketed variables, and methods can be accessed from a child class, even if they are separate scripts. Private variables and methods can be accessed from child class, even if they are separate scripts. If class C derives from class B, which derives from class A, class C only inherits behaviors from class B. These people are jerks. Like, see, this is the stupid stuff that I don't like when people do things like this. They're like, on your certification exam, they're gonna give you stuff like this or something. When it's like, oh, so I actually know how to do this, but you're not going to give me the paper that tells me how to do it, because you're gonna give me you're gonna give me an option like that. Not all of them are true. But I know 2 is true. So that means it's 2 and 3. Unless somehow it isn't. But you know, I'm willing to take that risk. More so since they just let you retake it constantly. Which is nice. If you were programming an application that allowed users to configure their own vehicles, how would you use the concept of inheritance to structure the code in a way that minimized redundancies? We just create a car class. A base class, Class A, includes the following code. Virtual void, greet. Derived class, Class B, that derives from Class A includes the following code. Greet, and you're overriding it. If only Class B is instantiated, and the greet method is called, what will appear in the console? Wait, what? How are they using the term instantiated? Because you're overriding it, it would only show what's in B. Is what I would assume. So I'm going to say it would only say, how are you? I guess 1 and 2. This is just what are the principles of abstraction, pretty much, like where you'd use it. So I'm saying to protect your code's privacy, which I mean, still seems like it's not really needed to me at all. But whatever. How would you replace the public variable below with a property, which has improved security, and can still be accessed from other classes? Pretty sure you'd use the get and set. How would you recommend improving the following code in order to improve its reusability? Display info. So you're displaying info of some kind. That's what this method is doing. Like, see, I kind of understand what methods and classes are now. That's good. Hmm. I mean, I feel like using an array would be easier, but reusability, if you're using it for other things, I think creating different methods to display the name, the addresses, and phone numbers would be better. I think that would help just to know how to get everything. The following example is of code logic that is very difficult to understand. Great value. So if bool1 results in 1, then return results. If bool1 doesn't result in 1, then bool2 results in 2. Or if it results in 0, okay. You're making the result equal. Yeah. So if you called great value, it would just return one of those numbers, but it wouldn't return results. So it wouldn't technically return the same result, because it's not going to return the word result and the number. Or rather, it's not going... Well, no. Because the result is a flip. The result is a number right now. Result is 0 right now. And looking at these things, they're saying result would equal 1. Or so on and so forth. The result always equals 0. But then if you have true, then it equals 1. If you have false, it equals 2. So I guess it's the same. I don't know if they're going to be jerks and say it's not the same because it doesn't have the word result as a float. They both are doing the same exact thing, though. They're both returning a 1, 2, or 0. Though it's not defining it as a number. I don't know if that would work. I don't know. I'll say false and we'll see. Which of the following statements about variables is true? Why can't they just make it yes or no? All of variables is derived. In derived, child classes cannot be accessed by its base class. Property. Public access to a private variable with getters and setters. Local variables can be accessed from all methods within a single class. A property provides public access to a private variable with getters and setters. I mean, I'm pretty sure this. Script loop. Which of the following scenarios is most likely to cause performance issues? Mr. Owl, which of these is going to cause issues? Extremely far away from each other in a scene. An object with many rigid bodies, each colliding joints, making a mesh collider. Instead of leaving it its default. On a mesh collider using a compound collider made of overlapping box and collider instead of using mesh collider. What does this word mean again? I don't know, I'll say that one. What I thought. I got that first one wrong. Oh. Didn't I actually think I got that right? Oh, that's stupid. They just have no vision. Okay, well, instead of looking at what's wrong, what did we get right? Okay, so that one was right. Okay. I hate those crackers, and then my water's already out. Can I refill my water really quick? Water. Visage of the Soul. Okay. Let's copy and paste all of these to a Word document. Oh, the way that any college student should always do their work. Even though that I'm not a college student anymore, but in spirit, I went to college, so it's the same difference. We all keep the spirit alive. The Final Fantasy Spirits Within. I've never even watched that movie. I wonder what the heck it's about. Does it even have Final Fantasy references? Or is it just like random weird sci-fi movie that they just made and thought was gonna be good, but then everyone didn't like, and then they just reference it in their other game. Their other game. Luckily, this one isn't as long as the other one was. That's nice. The other one had like 20 questions or something. This one's only got 12. That is a lot more manageable. I'm thinking I might just post like the actual answers on somewhere, just because no one had them anywhere. Though I don't think anyone would care. I don't think anyone would care. Okay. Now I got everything. Retweak. We take a quiz. That is true. Question 2. Why might you want to use an extension method? Incorrect. Extension methods effectively allow you to add methods to existing classes that could otherwise not be added directly. This means that these classes do not need to be recompiled either. Effectively allow you to add methods to existing classes that can be otherwise edited. Why might you want to use extension methods in C? And I answered, in order to extend functionality of existing methods using the same name. So is it easy to add methods to existing classes that could otherwise not be added directly? In order to add more parameters to an existing method, I guess, is what that would be? Question mark? Yeah, brother, it was 3 and 4. That's dumb. I don't care for now. Create base car. How are you? Question 6. 1 and 2 only. Question 7. Public int score, get set. Question 8. Wow, I got these ones all right in a wrap. Create new method names for display, address. Then call them back. That's how I would handle it, at least. And then question 9 is true. And question 10 is property provides public access. Okay, and then question 11. We have the player loop is the container, all the code for the Unity application. Player loop. And question 12. While simple physics join can be quite fast, the underlying math is very complex. A joint is setting up a system of equations for your rigid body's position, velocity, acceleration, rotation, etc. If you set up something with lots of different rigid bodies, with lots of different joints, all of them colliding, all of them needing to meet the requirements of their joints and not penetrate collision, it can be extremely expensive very quickly. So rigid bodies that actually meet. So an object with many rigid bodies, each with colliding joints. Okay. Oh, got a little EXP and everything. That time we still got 2 wrong. Huh. Weird. Still incorrect, huh? Okay. Wait, I don't understand. I don't understand why this one is wrong. Maybe because I didn't read it. Okay, well that one's true. Number 4, did I get number 4 wrong before? No. 5 was correct. 6 was correct. 7 was correct. 8 was correct. 9 was not correct. What did I get for 9 this time? Oh yeah, 9 was true. Do I have that one down? Okay, 10 was correct. 11 was not correct. What do I have for 11 on here? Player loop. Actually, I'll just do this. And then number 12. Okay, there we go. You know what? You know what? In order to extend the functionality, in order to more parameters. Well, I pretty much answered every single thing for that one, so we'll see. This one I don't get. For number 3, private variables and methods can only be accessed by derived classes if those classes are nested in their base classes. For number 4, C classes would actually inherit from all of base classes, which would include B and A class. Oh, so it's 1 and 2, right? So then it would be 1 and 2. I think. I think that would mean it'd be 1 and 2. Property provides... Okay, there we go. Finally. I got number 2 right. I mean, of course I got it right. I got it right in the first place. I never had it wrong. What are you talking about? I had everything right from the start. That's just how good I am. I didn't copy the whole thing. I see what happened. That's weird. Save that for later. Okay, we're good now. Okay, so this says 30 minutes, but we've seen those be misleading before. So let's get into it. You want us to submit something, design a project, create a new repo, do your initial comments. So we want to use the repo again. Reprocessing stuff. Let me see. They don't have anything for us to download here, so let's see what they want us to do. Just in case we refresh this mission while you're looking, please be sure to complete this content before attempting the submission. Okay. In the previous tutorials, you learned about the 4 pillars of oriented programming. In the submission challenge, you'll create a new project from scratch demonstrating each of these pillars in the code. Carefully plan your program's architect at a high level before you begin coding. Along the way, you'll have an opportunity to practice branching and merging code using version control software. This challenge is not going to be easy, but you'll be a more thoughtful, strategic programmer by the time you complete it. A successful submission will include a link to your project's GitHub repo, showing multiple comments, and commit messages in at least 2 branches, demonstration of abstraction, higher level methods that abstract unnecessary details, demonstrating of inheritance, parent-child classes, demonstration of polymorphism, method overriding and overloading, demonstration on encapsulations, getters and setters. Create a new repo and do your initial comment. Okay. Design your project. Not too worried about that. Create a branch for your title screen and commit changes. Branches are incredibly useful for version control developers. If you'll implement a new feature, you'll merge the branch back into the main branch, then deal merge conflicts. Merge your branch, the master branch. Work on it, submit your project. Demonstration of inheritance, demonstration of polymorphism, encapsulation, abstraction. Do a screen recording walking us through it, and then post it. Highly recommend that you comment on at least one other creator's submission. Okay. Yeah, I'm probably just going to submit ball drop again. Version 3. Version 3 ball drop just dropped. You got your balls? Or do I have yours? Oh. Okay, so, let's see. Just want to put up the get set stuff. Okay. I wonder if anyone actually looks at these, you know? Or could I just submit anything and they wouldn't care? Or does someone actually go through and review all of these? What do you think? But yeah, I don't think I need anything else for that junk, so I'll just save this other junk, get out of there, make sure this stuff is saved, get out of here, and we'll bring up ball drop again. We'll get the ball to drop once more. Yes. We'll name this branch we'll name it this. Programming theory in action. So all the changes now will be on this branch while we're doing it. So it'll just be a way to show us, well, to show people what we're doing. To show the world what we're doing. But okay, we got that up. Load up our game manager again. I think what I'll work on in this version of Ball Drop is making it a bit more playable, because we can't hit those things in back. It might be a good idea to have like a power meter on the ball. It could be a good idea to have life on the ball. We could clean up some redundant code that we don't need anymore. There's different things. One thing I can do is over here. Hopefully this doesn't break my code. So, let me just make sure. If we just get rid of that, and then do this, and then save it, does that break everything else? I'll just make sure it doesn't break everything if I load our game then. Okay, so ball location. Why did I name it ball location? I should not have named it ball location. I should have named it like throw ball. Well, no, I guess this is defining when the ball dies. So how would I tell it if the ball falls through 3 times? People -1 the pace. My game player gets points when he makes two balls collide with each other. When the balls collide, both of them are destroyed. I know there has to be a simple way to count the score that I just didn't realize. Destroy, undestroy, or just undisable won't work. Simply can't find a way. Just create a score for the ball that would be indicative of its life. Hmm. Hmm. Oh.
To black.
That is a gross display. Show me your code. Yo, dude, show me your code. So you would use antivirus? Hmm. Okay. Well, I think I can do this real quick with this coding that I see here. But first, let me try to fix up some other code really quick. So, the play button. Let's start game. Yeah, maybe it doesn't matter too much. I feel like they're so redundant. Let me try this. Let me try setting this up. The play button's fine. That's fine. Uniform that better. It's high to play. We have high score. How to play is 1, high scores is 2. So okay. So
can just get rid of that one completely. And then we can just set all of our other methods. Okay. I actually do it with this too. Alright. Okay, we got 4 buttons for this. Okay. Let me get rid of all those. Actually, instead of that, I can put the load new scene on the title screen. And I can just connect the onClick to the title screen. Correct. Did I put the return button on the other thing? It should be here. If I do this, don't I not even need to initialize it? Didn't I do that with the reset button? Yeah, I don't initialize it on there. Okay, so I shouldn't need it in my load scenes either. Though I think the problem is these aren't public. Okay, now we should be able to see those over here. Really quick. Oh, yeah, I'm a dummy. I'll put the return on these ones. It's not a big deal, but could have put those somewhere else. Keep it. I don't think it does. Oh, okay. display. Okay. Okay. Let me just make sure if this works or not. All of those should be good now. Okay, yeah. All of those still function fine. Okay, good. So we have that up. Ooh. Well, maybe I should clean that up a little more. It's fine. Hmm. Okay. So we cleaned up our code a little bit. I think our health bar would be a good way to show what are we supposed to do? Demonstrate inheritance of parent and child. We're inheriting a bunch of stuff from Game Manager, so I think we do that fine. Method overriding and overloading. That one, I'm not sure what we would use it on. Encapsulation. There you go. Okay. Higher level methods that abstract unnecessary details. That's a good one. Where would I put that? Doesn't even need the data method. Moving box. So I could do this if I wanted, right? You just see if that works. Okay. You can still fire the ball. That all works. So I think what would be smart here those. Six seems okay. First, we're just making this area a bit smaller. Probably should, but there's a lot back there. Then we have our moving on. Yeah. You're getting stuck right behind. That's kind of funny. Those are the right ones.
Okay, so it can reach back there. Alright. That's a bit better. We really should have made these gold boxes a prefab. Honestly, I could just do it, no? Gold box. Wait, whoa, whoa, whoa. That's our moving box. Ugh. So actually, let me go into that moving gold box script. Huh. So actually, I make the moving gold box also. One. What's the natural stuff I have now? Oops. Okay, wanted to make sure position was right. Boxes. Let's focus on actually cleaning up all this stuff. Okay. Bounce walls, canvas. Keep the event system and lighting at the bottom. Okay, that looks a lot cleaner. Did I not turn the scripting stuff on? Oh no, I did. Okay. Okay, so we have all of our tabs a bit neater now. Oh. We made the goal box prefab stuff. And the good thing about these prefabs is that we can now edit these. I'm kind of curious. If I make that 5, I make that 6, I make this 7. I'm just curious. Yeah, I would need 3 different Dendrite coins if I wanted to do something like that. That being said, I can do that. I can make different Dendrite coins if I really wanted to. Because now that I have this, I can just duplicate both the interwalls twice. Or I can just do it once. Yeah, I'll only do it once. Okay. And then I have to change that. So we'd want these to be public instead. Doesn't that count as overriding it? I don't know if it does. I'll make this one like 100 points. No, that's too much. We'll make this one like 20 points. We'll make the speed, we'll make the speed 4. Then, we're on the start position. Why are those positions so ridiculous? Oh, right. Let me just do this for right now. Okay, yeah. It's just because it was getting messed up from this. Wasn't going off their individual locations. Okay, so those are the locations we want. Only 22. I can still do negative 22 though, right? Might does 0 actually work? Maybe like 1. That's a bit more centered. Right. That's it in the first place there. That's what I like to see. Oh yeah, it's colliding with a Lambda. Slide 1. Box making balls. Yeah. Wait. This is the best. I want this one. Okay, so where was the thing? Forget what this was under. I thought it was under project settings, wasn't it? That was. Ugh. I forget where you go for this. Been too long. Oh, it was under physics. Okay. So the box making walls. Moving box making walls. All the left. Okay, so let's just see.
Oh wait, what's happening then? Oh wait, is it hitting the wall? Oh. That's why. That's a little harder. Hmm. That one is a little harder. We don't want to go through all of the glass walls. Hmm. I usually never got the balls in there, so I didn't think about that. So what we would have to do is take the player box. Okay, so it's the right one. Oh yeah, it's all messed up because of that. Here. uh, Man, I wish this stuff was easier to see. I think that's as good as I'll get it. Okay, then I want to rotate it. Scale can be lower. The only unit is as big as the box. The box is not as big as this. So about that, it's okay. How thick is the other glass walls? Well, that would be thick. That seems about good. Why does that one seem off? Look at that one. I guess the room is slightly slanted. Oh well. Okay. Cythron. Okay. Left entry wall defined. So all the entry walls are fine. Well, the player will never see that part. Smaller. Oops. 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 Hmm.
Oh yeah. Oh.
I don't know if I did this. I didn't realize I wasn't showing this. Also, that should be correct now. Okay. There we go.
That is better.
Hmm. Like, Hmm. Actually, just play the sound effect from Game Manager, can't I? Uh, I almost forgot I was streaming. Like, oh yeah, I'm doing this. I'm getting there. Want to register when the ball hits the ground. Yeah, I have no way to keep track of that. I would need to keep track of it somewhere else. Man, this would be easier if I just put this on somewhere else. Honestly, why do I have this here? Why don't I just have this in the game manager? Yeah, that is a good question. I don't know why I don't just have this in the game manager. Staring at it, it's like this script is not needed here whatsoever. It's literally not needed at all. Everything that I do here, I can do something. Okay, hang on. Tracking balls. Health. Let's test that now. I mean, technically this is not doing anything, so I'm just going to remove it. Well, that's not supposed to happen. Let me look at something. Let me look at something. What is the thing? Oh. Maybe I just can't do it like that. I mean, I still could probably switch that out, but whatever. So I want something else to keep track of the ball hitting the ground. Okay. That way it'll trap that. But I don't know. Okay, let's see what happens when we do that. Look at my game manager again. Okay, that actually worked. Oh! Well, there we go. Okay, so now the ball hits the ground. Oh yeah, I didn't even show it. If you look over on my giant stream of game manager info. The ball is destroyed when it goes into there. But if it hits the thing at 3 times, you can see the 3 is right there. Then we get that, and we have to restart. But we can make a little live system thing later. For now, though, I think I'll end there. I've done this a bit today. I'll have to fix up the walls more, do some other junk, but we got some things set up a little better now. So I'll save all this up. We got rid of those redundancies that we had in some of our other code. Ball location does not make sense at all for what we're doing, but that's fine. It does what it's supposed to do. It does what it is supposed to do. So for anyone who might have popped in, thank you for watching. Hope you enjoyed learning along with me as I do this stuff. I think I'll be able to submit this tomorrow. If I work on it tomorrow at least. I don't think I have too much more to do, because I feel like we used inheritance a lot. And method overloading. That's the thing that I'm not sure about. I feel like I used everything besides the method overriding, because I don't really know where I would need it. Maybe if I had a charge up meter or something for the ball, I could try and figure out something for that, but we'll have to see how that is, I suppose. Either way, I'm gonna go for now, so catch you later.